Okay. All right, we're back. Hopefully this time's gonna work because this is my second time recording this. For some reason, it doesn't work. So I have to redo the whole thing. Okay. Anyway, that's fine. Um, consider it consider it like community service. So we're I think it's part three on the machine learning from Kaggle course. Recap. We were using I think housing data from Melbourne to predict the housing market and to use that historical data over here, the training data, as to train the model. Um, and now we are going to build our first machine learning model. All right. So I'm just gonna minimize this and probably make it bigger. It's easier to understand and to see. So the first time, what we're going to do is just import pandas. It's a data frame library, and then we're going to point it to the um, um, data set. In this case, it's on the training.csv. If you look at over here at the workspace, you don't see it because I think it's kind of hidden, right? The home data for ML course is not here. There are just two file data, Melbourne housing and housing prices competition. Um, anyway, so and then we are going to use the Panda library to read the CSV file and then point it at home data. And then we're just gonna set up this as a checking mechanism whether it's correct or not, right? The because this is like a learning exercise to build the model. So right now, the first step one, is to specify the target, the prediction target, which is the sale price. We want to predict the home sale price, right? Given like the the number of bedroom, the how big is the lot size, how big is the house size, whether it has a basement, and so on and so forth. We want to predict what is the sale price, right? Is this 100,000, 1 million, or 10 million, or something? Okay. So we are going to print the list of the columns in the data set to find the name of the prediction market. The way to do it is just home data, because home data is our placeholder for the CSV file on the trainings set, right? And then we're just gonna do dot column. So if you wanna just click tab, give you a list of methods that you can use. One of the methods, if you're, I hope you're all familiar over here with the object-oriented programming, it's columns, which basically is gonna print out all the columns on that particular data set. So if we execute this, it's just gonna list out all the columns, right? So these are all the columns. Yeah, I think correct. Yeah, I think it's got a number of them, and then we can just also print out all the as the head. I think I have used this to print out the first five rows on that particular training data set that we have. So from 0 to 4, and list all of uh, the the columns, right? And then at the end, we should get a sale price here. Yeah. So given all of this, like say house number 0 has a 25 frontage, 8,450 lot area, and blah blah blah, and the price of that is about 208,000, right? US dollars probably, right? And this is like your build 2003 and so on, right? So, and then, oops, what did I do? Uh, I'm accidentally restarting the kernel. Okay, never mind. It's restarting. Let me see if the settings is correct. Yeah, GPU is on. Okay, we'll just wait for a while. I don't know where I did. I just like swiped to the right earlier. That is so weird. It's still preparing. But we have to restart this one. Should I restart this one? No. Okay, I'm just gonna restart this again. See, hopefully it works. Dun, 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 dun. Oop, have to sign in again. Okay, sorry guys. It seems it's stuck. Still preparing the kernel. Oh, so by the way, this is the exercise that you can take a look. I'm just trying to kind of like this is like a cheat sheet for me to see what's going on, the syntax and everything. Okay, good. It's running again. Okay, so I'm just gonna restart this again. Run the code. Um, Warning, ignoring repeated attempt to find the globals. I have no idea why is that warning. But the setup is complete. Okay, so we're gonna run this again. Home data.column, print out all the columns for that data set. This one is printing out the first five headers for that particular data set. So you can see here from house 0 to number 4. And the next step is we are going to put um, the the y pointer as the output. So we want to put home data dot sell price because we want that's what we want to get as the output. Right. So we run that. It's correct, and then we want to see what's if the solution should be correct because otherwise it's gonna give you the error. So so you can see the solution is this one. Right. It's precisely the same as this one. So it's good. I'm gonna minimize this one. Okay, step 2, create the X. The X is the input, right? So the step 1, we already created the Y with the output, the home sale price. Now we want to create the X. So we're gonna create a data frame called X holding the predictive features. So in this case, we are going just to choose 7 features from I think the available, what, I think 40 something. If you can look here, let's say home data dot um, let's see. I think there's like 80 features, something like that. It's quite a number of them. Uh, ooh, where is that one? Nope, 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 nope. Not this one, not this one. Floor, get, head, history, index. I have no idea. What is that? Uh, Largest. Um, where is that? Can I just say column? Columns like that. Okay. How about uh, is there a count here? All? But all. Okay, that's all. It doesn't say how many. Let's see. Uh, it should be like a function that count all of the, how many of those? Um, couldn't find it. Few? No. Well, you can count it one by one, but I think it's about like 80 something. So anyway, so we're just gonna create, sorry, we're gonna choose like seven features from this, right? Which is the lot area, your build, the first floor in terms of square footage, the second floor in terms of square footage, the full bath, if there, I think there's a full bath, yes or no, uh, bathroom above the ground, and then the total rooms above the ground. So after you created that list of features, use it to create the data frame that you'll use to fit the model. Okay, so let's see. So this is what I did. So you just put it under feature name, for example, and you put all of the features that you want inside the bracket with parentheses and separated by comma, right? And then after that, you put it inside the X. So this is what I did. Home data in parentheses features name. So if you are not sure how to do this, I'm just basically copying the syntax from this, from here, right? So your first machine learning model. So basically it gives you the example. I'm just going to copy and paste from here, right? The syntax, because I couldn't remember the syntax. It's just overwhelming. I kind of forget whether it has to be using a bracket or parenthesis or comma or what have you. So, okay, right? So we're done here. It says it's correct. Um, and then you can print out also the solution, which is this two, which is the same as the above here, right? The feature names and the X. Um, and then you want to review the data, so you just want to print it out, right? You just want to print it out, make sure it contains what it's supposed to contain, right? So right now, if you print x dot head here, it's just going to print the first five columns, and it's just going to print the seven features that you choose to be included as an input, as a kind of like the most important kind of determining factors in order to predict a house price, right? So there's these cells. So in I think in the real world, you want to consult this with like a domain expert, right? In that particular field. So for example, in this case, then you want consult with a realtor who has been working in the industry for, I don't know, like 10, 20 years for something like that. And you'll ask them, hey, what do you think about this most determining factors in terms of the sales price of a house? Is it the number of basement, the number of how big is the house, the number of windows, whether it has cul-de-sac, whether it has a swimming pool, whether it has kitchen, whether it has basement, and so on, right? Um, but if you keep on studying further, or if you heard about the deep learning algorithm, this kind of take away of that the necessary of the domain expertise. That's what I like about deep learning, because the deep learning model basically um, is kind of like um, if you so there's data science, and then you have this machine learning model, right? And then in a machine learning model, you can choose like a different kind of algorithm, and one of the algorithm is called deep learning. And with if you're using deep learning, basically you're saying that to the machine that you kind of let the machine determine what are the most important features. So you don't have to pick and choose. So in that sense, you kind of like you kind of don't need in quote the domain expertise, as much as you need it in a machine learning world. Um, because yeah, in a machine learning world over here, you kind of pick and choose which features that you want to include in the computations. But in the deep learning world, since the algorithm can accommodate like hundreds, thousands, or even 100,000 of parameters, then you kind of like, okay, do whatever you can. I can just like input everything into the model and see what's the machine can came out with. Uh, with that said, that's why there's many this discussion about that deep learning model is kind of like a black box. It gives you a prediction of highly accurate prediction, but it's kind of hard to analyze why that model give that specific kind of prediction. But anyway, this is kind of off tangent. We can talk about it later on. So anyway, okay, so that's step two, which we already put the determining the features that are important, put it in the data frame, and after inputting inside the data frame, and then we are just see it if it's correct or not. And step three, after we put the x and the y into a placeholder, right? Step three, we are so remember the machine learning model is basically using a kind of simple or how is it? Simple algorithm. You can think of an algorithm is like if you go back to your high school mathematical algebra, which is basically an equation, solving an equations. The most simple equation I could think of is a linear equation, could be like y equals to mx plus b, right? So the same thing over here, machine learning model is you if you choose that equation y equals to mx plus b, you already choose the x, which is the input, you already just choose the y, which is the output, and right now you are choosing what kind of model. So in this case, I'm choosing, let's say, y equals to mx plus b, which is a linear model, right? In this case, in this scenario, Kaggle exercise is choosing a decision tree regressor model instead of a linear model, right? That's what it's called. And then we're going to save this uh, into the Iowa model, right? And we're going to ensure that you've done a relevant import sklearn because the model is from the sklearn library. And then we're going to fit this model, the decision tree regressor, right? That using the X and Y, right? So how do we do this? So first you have to import the model from sklearn.3, right? And then you want to put it inside, um, you want to call this model, and then you want to make it reproducibility, right? The idea of reproducibility means that when I'm doing this uh, kind of exercise or testing or training the model, it's also can be reproduced with other data scientists or other like machine learning engineers, right? It's not just me who can reproduce this, but um, so and this is very important in science or even in I think engineering. So given a specific input um, and a specific problem, you always want to uh, uh, get the same result, right? The same output, no matter who test the model, right? So in order to do that, you want to specify a random state, and you can specify like 1, 2, 3, 4, and so on, right? So in this case, I'm just gonna 2. It's an arbitrary. You can just choose 1 if you want. It doesn't matter. But this is kind of necessary to make it reproducible. Okay. Um, and then after that, you put it into the placeholder IO model, and then you're gonna fit it. You call dot fit with the input and the output x and y, and then you're gonna check it whether it's correct or not. So we're gonna run this, and then it says correct. So if you erase this one, for example, right, and then it's gonna do error, right? It says like missing argument or whatever, but actually it's missing that statement, this statement, the random state. You can like make it like 3, it still is gonna work, right? And then you can compare the solution. It turns out to be correct. The solution choose to be equals to 1 over here, right? But the idea is you choose a specific constant random state, right? And then the last step, we're gonna use that model because we already kind of train it, right? This one is to train um, the model basically. So we already have a kind of like the I think the parameter. So it becomes like y equals to 6x plus 7 or y equals to 10x plus 3 so on instead of y equals to mx plus b, right? So this one, after you run this model, what happens is, I think the model already picked the specific parameters, right? So it becomes already like an algorithm. I think, I'm not sure. Can I just check this one? Okay, so, oh, but this is just describing the algorithm. Okay, can I do something here? Um, predict score, splitter tree, no. Random state, no. Okay, I'm not sure. Anyway, okay, so, and then we're gonna use this as the model, the Iowa model, to predict, and then we're gonna input the X, right, to predict. So use this, and then this is the output, right? But if you compare this output, right, with the Y output, so we're gonna print the Y hat, you can see it's exactly the same, right? This is 208,500. This one 208,500. This is 181,500. This is also 181,500. This is 223, and then this one exactly the same. Now that's a homework for you. You think why um, it's the same? Why it's not different? Okay, so uh, this you can print out the solution. The solution is this one, which is basically the same as um, let me see, the same as, yeah, this guy is, right? Okay, and then you can prediction view. I'm not sure what it is. Okay, you just put all of the in an array. Okay, so this is the kind of the homework. Use the head method to compare the top few prediction of the actual home values in Y, which is this guy. Yeah, we just print out the first five sales price. Um, so you're comparing that top few prediction to the actual home value. Anything surprising? Because now it's the same, right? You'll understand why this happened if you could keep going. So we're gonna continue this next time, but we're gonna keep on going. So basically, we already built a decision tree model. Uh, if you're still confused about what decision tree model is just think about a linear algebraic equation. That's what it is. It's basically a function, a mathematical functions, right? It could be a linear function, it could be a quadratic functions, it could be an exponential functions. It's just a mathematical function. That's what um, um, a machine learning model is. In this case, it's called decision tree, but it boils down to a mathematical function. Um, if you're still confused, you might want to brush up your algebra. You can go to Khan Academy. Khan Academy is really good in explaining the basic and fundamental kind of uh, in math, in biology, in what have you, right? I love Salman Khan. He's so brilliant. Um, so it's natural to ask how accurate the model's prediction will be and how you can improve that. And then you can learn how to do that with the model validation. So in the next session, we are going to continue on the model validation. The idea is after you got your prediction model, right? You want to know how accurate is this, right? And this is where the test data will be handy. So we're given this test.csv file over here, and we haven't used it yet. So far we're just using the train.csv, right, to train the model. And now we already got the model, we got the mathematical functions locked in, and now we want to know how accurate is this, right? Because if it's not accurate, then you don't want to kind of like put it in a for public usage. Then people probably will use your model and then will predict the housing uh, 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 not correctly, and then they're gonna buy a house that is supposed to be like a 1 million, but they'll buy it in like, let's say, 2 millions, for example, right? And then they're gonna lose a lot of money, right? Right. So you want to have before you put it up in the market, or before you make it like commercialized, or before you like share it to the public. You want to be sure that it's already tested, it's quite accurate, and the model, it could be like kind of like has value for people who are using it, right? So with that in mind, you want to use testing data, right? To test how accurate is it, like 90% accurate, 95%, 98%. So that process to compare basically with your prediction model with another testing and like outside data, testing data, it's called uh, a model validation. And that's hopefully is gonna for the next session. Thanks for listening. Um, please ask any question. I'll try to answer any questions. Um, and happy learning. Stay curious. Hopefully, we can get through this together into the data science world. Okay, bye.